Welcome to the Science and Beers podcast with me, Mick Mickey. Talking science and drinking beers with researchers down at the pub. We cover a new topic each episode, so join us with a brew and let's cheers to science. This episode is going to be slightly different in that this week we are out in the field, albeit a very wet field at that. I was out helping two people from the biology department of the University of Southern Denmark, PhD student Susan Guldberg and master student Mikkel Haumann Jensen. So I brought with me a handheld recorder and had a little talk with them as they were doing the work. It was a Zoom handheld recorder I had with me, so sometimes the audio might be a little bit interrupted with the sound of the wind, but you'll also get to hear the sounds of the field, us wading through the water and the birds in the background. So it will be a different format to the podcast this week, but I'm really curious to hear what you think about it. So do get in contact, do let us know if you would like to hear some more, live action science podcasting. So I'm walking in knee-deep water in Gyldensten Strand. It's a beautiful expansive wetland, I would say, on the northern coast of the island of Fyn in Denmark. And with me is Mikkel Haumann Jensen and Susan Guldberg Grøngaard Petersen. They're both from the biology department of the University of Southern Denmark. Susan is towing a rubber boat with some electronic equipment in there and a couple of sediment cores. A sediment core is a glass or plastic transparent cylindrical tube, and you stick it into the sediment here and it comes up, and what I'm looking at is the bottom 2/3 are all black and then the top is a little bit less black. What do we have here, Susan?
Well, this is the soil from Station 5. Did we call this soil here and not sediment yet? Because this used to be farmland just 6 years ago. And as you can see, as you said yourself, it's very black, so we have very reduced conditions. That's basically it. Very broken down organic material that's been gathered in the corner.
6 years ago, It was farmland, but now it's up to our knees here in water. Can you tell me what happened?
Yeah, well, actually, we have to go further back, because 150 years ago, this was seafloor, where we're going now. And then Denmark has been draining a lot of land to produce food for the population. So this was all drained, and they put up dikes on the outside, which made this into farmland, and it's been farmland for 150 years. But then some years ago, the O.V. Jensen Foundation bought the land and decided to flood it again. And instead of turning it all back to ocean, then they decided to make both a coastal part, which is open to the ocean, and then this freshwater lake that we're walking in now.
Okay, so it's fresh water here.
Yeah. Well, it's supposed to be fresh water, and it was, but it's a bit brackish. We found some algae last year, which is supposed to be a marine species. And when we looked into it, it turns out that the lake actually has a salinity of 2 ppm. So now we're following that to see if it decreases or what it is. And it's probably because the salts are concentrating in the water when you have runoff from the fields, and the lake doesn't have any water going out or into it, so it's only dependent on the precipitation and the groundwater level, so it's just like a steady soup all the time.
Well, I tell you what, we're walking here to the next station so you can collect your data.
Yeah.
We'll check in again whenever we get there, and then I'll talk to you about what it is exactly you're looking for here.
Okay.
So we've stopped wading through the water now. We've stopped, the boat is stopped. There is, I would call it a floating bucket hovering on the water surface, and it is connected to a computer which is connected to something called a gas met. Susan Gulba, what's going on here?
Well, the gas met is also a gas analyzer.
Yeah.
So it can actually measure the gases in near real time, so like a 5-second delay of what comes out of the water. So it's connected, as you said, to the computer, which have the software that I use to see what the results are, and then it's actually pumping air in from the bucket and out again from the bucket, so there's a constant circulation. So whatever comes from the water into the bucket, I get a measure of.
Okay.
On the machine.
So the theory is that in the sediment,
Yeah.
there's a bunch of microbes, and they're producing gas.
They are, yeah. Well, there are different. There's like a mosaic of different microbes in sediment, or soil, as we call it, like this.
Yeah.
But here in the freshwater part, the special microbes that can produce methane are pretty close to the surface, and they, whenever they produce methane, which is a gas, it will slowly diffuse up to the water and also up into atmospheric air. Some of it will get oxidized and not escape to the air, but some will escape to the air. And
I will say on the walk here, there was a few bubbles coming up as we disturbed the soil.
It can escape from both diffusion, but also from ebullition, which are the bubbles. So that's a bit different because they kind of the gas in the soil will sometimes form these vacuoles, which will be like bubbles laying in the sediment. So whenever the sediment or the soil is disturbed, or actually sometimes spontaneously, if the pressure changes, it can be released as a giant bubble instead of just diffusively as molecules. So that's two ways of releasing methane. And the bubbles are they're actually the biggest source of methane out here, because I don't know if you can imagine that it's easier for the methane oxidizers to get to the molecules compared to these big bubbles, which escape rather rapidly up, especially when the water is not that high. But with this machine, I only measure the diffusion of methane, but we also have some traps that measure the ebullition. So we have both of these compartments of methane release covered, hopefully, when we measure the methane release out here.
So you can get a clearer review of the methane being released all over the flooded area.
It's really hard to estimate the bubbles because, as I said, like the diffusion, we can if we cover the different station types, so the different types of bottom that we have here, like the hard ones and where the organic content, we can kind of map it out to the whole lake. But the ebullition is harder because we don't know where these pockets of gas are and when they're gonna be released. But we leave what you call it traps out here for 24 hours, and then we look at the volume, and then we measure the gas back home at the lab. But we should just cover the whole lake.
Yeah, with a big bucket,
balloon or something to get the right measurement. But we try to.
So methane is a pretty potent greenhouse gas. Why are you measuring the amount of methane coming from this flooded area?
Yeah, well, you said the keyword, didn't you? Like, it's a greenhouse gas, and what we want to know, basically, when we form wetlands, or when we recreate wetlands, recreate nature, there's a lot of benefits, like higher biodiversity and nutrient filtration, and like the bird life has exploded out here at Ingsøen where we're standing. But unfortunately, the methane production has also gone way up, because before, of course, there was drained farmland, and that's really filled with oxygen, and oxygen is pure poison to methane formers, so there won't be any methane formation where there's oxygen. But right now we put fresh water on it, which means that the soil will be anoxic. So the methane formation is higher than before flooding. So the question is, like, before flooding we have this soil that will emit a lot of CO2, which is also a greenhouse gas, and now we have this anoxic soil. The CO2 release is very small, close to zero, but the methane release is higher. So we're trying to do a cost-benefit analysis of, did it make sense? Was it like a climate advantage to flood? And just interesting because we have to find out a way to mitigate our release of CO2 and methane to reach our goal to become CO2 neutral and to stop climate change. And wetlands might be one answer, but we have to know, they're not necessarily that great for the climate, especially if they're freshwater. Then at least we have to think about how to build them, and that there should be a lot of plants here, and maybe they should be deeper. And
I guess the plot really thickens if the question was only greenhouse gas emissions. Then it might be easy to find an answer. But I'm looking around here and I'm seeing a bunch of animals in the water, a bunch of different kinds of vegetation. I'm seeing lots of birds. It seems like a very rich area to me. And I imagine before it was flooded, it was farmland. So I guess it was just, I don't know, onions.
Yeah, so. Exactly. Yeah, before it was onions, and way before, which is interesting with this, is that we're standing on old marine habitats. Like this was sea floor once, and then it was farmland. And as you know, farmland does have some animals and birds belonging to them, but I think like the biodiversity out here has gone only up from it was made. So it's just a matter of finding the right compromise. Like, what do we want with these areas? Do we want want to enrich our biodiversity, or do we want to stop the greenhouse gas emission? And doesn't always go hand in hand. So that's what we're trying to find out. And actually, there are plants out here, especially in the coastal lagoons, to try and plant out some eelgrass and to make some stone reefs, and maybe we should try and put some sand out here. And we also talked about the next time you make a lake like this, should they try and dig out the soil, because the problem with the lake here is also that it's been fertilized for 150 years. So whenever you have a lot of nutrients in the soil, of course the decomposition will be bigger and faster, and hence the methane production will be bigger. So there's also these kind of questions, that this is really a pilot project that other people are looking towards. To when they're gonna make a freshwater wetland or a saltwater wetland. Both do's but also don'ts.
There's a prediction from the IPCC
that
sea level will rise between 1 and several meters over the next 50 to 100 years. So deliberate flooding is something that countries might have to do, or it might be forced upon them.
The sea is coming no matter what, and England is actually, it might more be a question of mimicking. We also have more extreme weather coming, so we'll also have a lot of flooding that's freshwater based. But the coastal lagoon is actually a way to where the dikes were actually opened and then move further into land. So we actually sacrifice some farmland that wasn't really economically valuable anymore, and then we opened up to let the sea come in, which is a strategy, or a climate strategy, or a coastal protection strategy that you call managed realignment. And in that way we can choose where the water can actually can go and take the pressure of places that we might want to protect. So the project of Gyldensteen is something they're looking to do in a lot of places in Denmark, and maybe also in the world, because we have to live with the water. And Denmark, like a lot of places, all the big cities that we have, they are all built close to water, because water was the way to get around. So no big city, or no coastal city in Denmark will escape the fact that they have to do some sort of protection. So some will build them walls higher, but it might also be a solution to kind of just choose where the water should go.
Yes.
Yeah.
Yes. Denmark is very much like their most popular, popular beer export. It's very close to water.
Yes.
Is the gas mat finished there?
I think so. Let's take a look.
Let's take a look. You got your reading there.
All right. Yeah, so I can do something with this.
Okay, so there's methane. We just measured methane.
We just measured methane, yeah. So there's a bit of diffusive outflow. So when I started it, it was around atmospheric level, which is 1.7 ppm. And now over 5 to 10 minutes, it's gone up to 3.9 ppm. So what I'm going to do when I get back in the lab, I'm going to take this increase, and then I'm just going to using the chamber volume and the flow of stuff, and I can measure a flux, and then I know, okay, per square meter, this much methane is coming out at this station.
Okay.
Yeah, that's what I'm going to do. And then I do this all year round, and then we have like a year budget of how much methane is escaping from Ingsøen. Sometimes I also do it at night.
Excellent. Well, we'll get packed up here and go on to the next station.
All right.
So here we are we've just stopped by a couple of different stations. Mikkel has taken the sediment cores. Susan has measured the methane release from the different stations around the area. Do we have much more to do today, Susan?
Actually, no. This is the last station. Then we are done for today.
Okay.
Yeah.
Now we'll get a beer.
I don't think so. No. Science and beers. That's for Friday. We're gonna drive home, but maybe we'll get some cake.
Okay. Well, that's good. So you've been working on this project for your PhD for a couple of years now.
Yeah.
Where's it going to go? What's the future of the project?
Well, the future of my project is kind of short term. It's ending to the summer, but the future of Gyldensten Strand is looking bright because we just got a new more funding for it, 5.5 million kroners to go for 5 more years, and then we'll see. And Gyldensten Strand is just going to continue being this pilot project where we can try out different restoration methods for wetlands and see what happens when we bring back nature to farmland. Because it's in ecology, you can't answer questions overnight. You have to wait several years. So that's it.
So you're one part of this project. Are there other people working on it?
Yeah. There are a lot of people at the Biology Institute at SGU in the ecology department that has some part in the Gyldensten project. So we follow both the fauna and the flora and the nutrient release and the greenhouse gas emission of the area, and it's also going to be a restoration project now, so we're going to put out stone reefs and eelgrass if everything goes well.
Is that to try to increase the biodiversity?
Yeah, and this is going to be in the coastal lagoon first and foremost, but it's going to be to try and increase the biodiversity by the problem in the coastal lagoon is that the earth is very clayey, and the turbidity of the water is very high, so a lot of the mussels have problems in there because they use a lot of energy of sorting out the small clay particles in the water instead of getting fed enough, so we need something to kind of hold down the clay. So maybe we're going to try and put sand on it, which is a method called sand capping, and we're going to try and put out stone reefs so that the mussels and the seaweed has something to hatch onto, which will hopefully increase the biodiversity out there. And then of course eelgrass will also stabilize the sediment and oxygenate the water and be a refuge for small fish. So everything is done with a view to better the quality of the water.
And that would make this area even more beautiful than it is.
Yeah.
Okay, Susan, it's been a pleasure helping you in the field today.
Yeah, thank you for your help.
All right. I'll see you at the at your Science and Beers talk.
You will. Yeah, definitely.
I hope you enjoyed that in-field recording of the Science and Beers podcast. For those of you who've been listening to other episodes, how did that compare? Would you like to hear some more in the wild science podcast recordings in the field or in the lab, let us know. I will put the contact details of this podcast in the description. I will also put some details of links to where you can follow the work that's going on out at Gudenstein. This podcast is run voluntarily for the love of it, so please consider supporting the podcast. You can do that at patreon.com/science and beers. Thanks for listening.